Okay, so we got our pieces here. They're ready to go. One thing we didn't do actually is we haven't actually normalized them. We want all of the pieces to be roughly the same size, let's say 1 unit across. That way later on, when I use the p-scale attribute to scale the size of the pieces, I won't have to worry about, the inherent size of the piece. Like I might have a small a point that says put a small piece here, and and I use the big piece on it, and then another one says put a big piece here, and then I instantiate this one to it. So they both end up looking the same. So let's normalize it so they all have a radius of 1, and then when I use the p-scale, we basically just multiply the p-scale times 1, and we know what to expect. So it's not too hard to get this to 1 unit scale. Essentially, go back to this transform here. Uniform scale, it's going to multiply it by some number to get it up to 1 size. And what we want specifically is to find the bounding box here, the size of the x, y, and z, find the largest axis, which in this case is this one, and then divide by that number. Or put another way, multiply, scale, multiply it by 1 divided by that number. But first things first is we need to find out which of these numbers is the largest. Because, for different ones, like this one looks like the x bound is the largest. So let's just go here, the uniform scale, press Alt-E to bring up a big ol' editor here, and we'll refer to the node before it, the piece null here, and let's find out which one's the biggest. So to compare sizes, we'll use max, and to actually get the size, we'll use bbox. So I'll say refer to piece, and give me the x size. So dx size, if you look up the syntax here, as you can see for bbox, you can find the minimum value of the bbox using the x min, x max, or we can do the entire size. So what's bigger, the x axis or the y axis? By applying that, we'll see it says 0.284. So that is the x-axis. And sure enough, it is larger. But of course, we need to bring the z into the game here. Now, in order to do that, we need to basically run another max again. This entire result here can be one of the, max takes 2 arguments. In this case, it was the x size and the y size. So in order to run another max, we'll feed this entire thing in as one of the arguments and the remaining axis, z, as the other argument. So I'll put another max up here and say, I'll just paste it. Z size will be the first argument, and the second argument, I'm just going to put a comma there. And because the expressions language doesn't care about new lines or anything like that, simply just by putting the end parenthesis, let's say here, this is the first argument, comma, this is the second argument, parenthesis, matching up to this first one, as you can see. So if I press apply to that, you'll see it's 0.348 now, which sure enough is the z-axis, which is the biggest. So I hope that makes sense. It doesn't matter. I could put enter there, put this here. It doesn't matter. It'll still work. I mean, obviously I can't put like a space here. That would break it. But in terms of splitting up arguments and with new lines and stuff, it doesn't matter. So like I said, we need to divide essentially by this number, which is the same as 1 divided by that. So I'll just say 1.0 divided by that. Apply. And apparently 0.286 is the magic number in this case. And by middle clicking and holding on transform, you'll see the largest axis is now 1. You can see how it grew it from, well, I should say, it grew it from here and also off-centered to here. Centered and 1 unit along its largest axis. If I go to another one, let's here, we see 1 unit along the x-axis. And we can see that all the other axes are always going to be less than 1. And that's all we want. We want to more or less keep it consistently sized. So let's throw a rest down to store per point the original point location here. We'll use that for, shading and bump mapping and stuff later, where we're just copying over the position attribute into the rest attribute. Again, that's more of a shading thing that we talked about in the previous lesson. And finally, we'll come here, save them out, put load from disk on just so we can see. And there they all are. And great. So now we are ready to actually instantiate these onto our points.